Hello guys, give me a moment, I'll link the video. Hello. I will also add a link to Wiki because today's lesson will follow Wiki heavily. All right. So, hello everyone for lesson 6 of C# Bootcamp. We will be learning about branching this time. Sorry, not about branching, but about versioning. Versioning your code. That's a very important topic. And today's lesson will be a lot of theory to grasp, but hopefully worthwhile theory. I mean, not hopefully, definitely worthwhile theory. Because in every workplace, no matter what it is, you will be using code versioning in some way or another. So, what's code versioning? Why do you need it? If for now you have been working alone, and if you have been doing so for more than a few weeks, you might have already noticed a few problems. How do you manage your code? How do you store it in a nice place? And what happens if your machine gets corrupted? You know, should you just allow your code to be lost? Or are there ways of preserving and keeping it intact? What if you work in a team with multiple people? Each person makes their own changes, messes up code, or fixes it, but you want to stay up to date. You want to get their code and submit yours. How do you do that in sync? And lastly, what happens if you are unhappy with the way work goes and you want to go back to a feature that you were happy with, to a version of code that you were happy with? What do you do there? Problems like these will be solved by code versioning. And the most popular code versioning system is Git. We will be learning about GitHub as well, because GitHub is by far the most popular code versioning system host. And you already know how GitHub looks like because that's where we store our wikis. So this is how GitHub looks like. You're familiar with it. You know, you have a bunch of stuff about which we'll talk soon. So GitHub, it allows us to host our code so that it's accessible for whoever wants to know about it. We work with Git through we can work with Git in multiple different ways, but the main one, or rather the core one, the one which is absolutely under everything that you will do with Git, will be a command line. And I have Git tools installed and some extensions that integrate nicely with my Explorer. So I can, open console here, so I will. And this opens Git Bash console and allows me to type commands. So this is how Git Console looks like. I'll try to zoom. Okay. And for example, if I do git status, it says the status of my repository. Command line might be and will be intimidating for beginners. I was intimidated by Git when I started several years ago, and I was having a hard time grasping what does each command mean. Therefore, I would recommend as a beginner to not use command line for now and instead use visual tools, which require you to at least have some understanding what you're dealing with and just have a clue. And then based on that clue, the tool will allow you to execute the right commands without knowing to need the exact commands you need to execute. Only hints. So let's continue learning about Git. What commands did I have in mind? When talking about Git, it's important to understand the simplicity of it because everything that you do with Git involves moving files between 3 places or in 3 places. So the first place is working directory. That's your local machine. That's basically your directory. That's this place, basically. Local files, that's working directory. Staging area is like the in-between, like the magical world before, in between actual Git, all the Git related things, and our own machine. So in between our own machine and Git stays staging area. For example, if I'm making changes and I want to start working with those changes through Git, I first need to tell Git, look, these are the changes that are relevant to you. Please do something about them. And I can do that with git add command. So if I do git add, it moves my files from working directory to staging area. And then files in staging area, I can then say, those are good files and I'm ready to put them into something that is workable. It's working. I want them. I'm ready to publish them. But I'm not publishing them to here yet. I'm publishing them to my local repository. In my local version history, basically. Anyways, if you would like to start, you will need to go to GitHub. And this is the link you will need to go to. Let's say a bit tedious, but okay. You'll need to go here and create an account and then clone the repository. And please let me know if I'm being too fast or too slow. As always, plus plus means I should go faster, minus minus means I should go slower. So let me know. To recap what we already know, Git is a code versioning system. GitHub is what hosts that versioning system, one of the hosts, one of the most popular ones. And Git works based on 3 locations: working directory, staging area, and repository. If you want to start working with Git, you will need to create a new account. And then when you have a new account, you will need to create a new repository. So let's assume that you already have registered, and this is the view you see. For example, if you click on your profile and hit your repositories, let's say this is the view you see. And if you click new, you will be able to create a new repository. Let's do that. I'll say test. Actually, I'll say lesson 6 test and create. And it creates an empty repository. And it says, quick setup if you've done this kind of thing before. So click on this and check it out. So you will need an empty folder. Or, well, it will check it out in an empty folder. So I will open Git Bash here. And I'll say Git. Well, I won't say anything. I'll just copy paste the command. Okay, I won't copy paste the command. I'll say Git clone, which clones this repository to my local. If you're running this for the first time, you will be prompted to enter username and password. So keep that in mind. And here it is, my Git repo. So I can add files. And if I open, oh, no, not this one. If I open Git Bash here and do git status, it says that this file is untracked. It means that I am I know that some files are in context that Git understands, but that's all I can do with that file. Either let Git know about it more, or work with it, or not do anything with it. So usually what you do with files in Git, you do git add dot, which moves all files in a staging area, working directory to staging area. And what happens next, if I do git status, you see it says, here is a new file. So before it showed untracked status, and now it's a new file. All right. Questions. Should we use Visual Studio to clone or Git Bash? There is no difference. Use the tooling that you prefer. If, however, you have zero experience, I would highly recommend using Visual Studio. Jodman asked, isn't it better to use git add star instead git add dot? I read somewhere that add causes problems. I had one and I started using git the star. I don't know. I really don't know. I never heard about such a problem, so I cannot answer. Do you like move to staging area when you're done for the day? No, you don't move to staging area when you're done for the day. You push your files when you're done for the day. Commit at the very least. You should always have your files in a remote repository by the end of the day, because anything can happen in between the end of a day and the start of a new day. So be ready for such accidents, because they can happen. Okay, let's go back, and please let me know if you struggle with Git, with cloning a repository either through Visual Studio, Git Bash, and we'll get back at you. So if you want to clone a repository through through Visual Studio, you will need to go View, Team Explorer, and then click this connection button. And you should see this window. And then Manage Connections, Connect to Project. Sorry, ignore what I said. You will need this Manage Connections if you want to connect to DevOps repository. But if you're using GitHub, it's easier. All you have to do is to paste the link to your repository, this one, and paste it right here, and then hit clone, and it will clone it. So if I do test3, it clones. Clone is a bad word. It downloads the repository and at the same time links it with the remote repository. It might sound a bit confusing for now, but we'll gradually approach the unknown terms and figure out what they mean. All right. So, mirror is a good word. It mirrors, but so what do I mean by linking a remote repository for a local machine? It includes all history. It includes the Git context. It gets all the changes that that repository had and adds the necessary Git context for us to work with it in the future and now. So that's what I meant by link and download. Okay, so let's say we have cloned the repository. And we start working with stuff. So as I mentioned, we have a working directory, which is our local machine, basically. Upon doing git add, we move stuff from local machine, aka working area, to staging area. So this is how it would visually look like. Anything that we have that Git doesn't recognize, we will need to add to Git. So that's how it looks like. And this essentially means that we can now meaningfully track changes for those files and even undo changes. Do we always need empty folder to clone a repository? Yes, we do. I am not 100% sure why, and this doesn't mean that the command folder has to be empty, but the path to which you want the repository to be cloned, to be downloaded and linked, it has to be empty or non-existent, like in the cases that we just demoed. It's important because I guess you might already have Git there, so you prevent that, and it will be a complexity figuring out if a file needs to be tracked or not. I'm not sure why is it, necessary to pull it into an empty directory. But let's not, look too much into it. That's the rule, and let's play by the rules. Have it empty, it's necessary. Why? I'm not sure. So we have a repository cloned, which means download and link. And we have some files staged, tracked. what do we do in order to add more files to our repository? So moving files from staging area, the in-between area, to a repository is just a matter of running a git commit command. So if I want to add a new file, let's go through the whole flow. I will do test, the whole flow. So first, git status, it says this file is untracked. And I say git add test.txt or just dot. And then I say git status, and it says here, this is a new file. So what do I want? What do I need to do to turn this new file into an existing file, into a file that I understand as an existing one? I do git commit -m and type a message. Basically, name my change. Added test.txt. And I hit enter. And if I do git status, it says, done. You are clean. There is no difference between staging area and repository. Repository. What is repository? Repository is a thing that owns the files, the code that we version. When files are in staging area, they are still not really versioned, they're just being tracked. So when a file is tracked, we can undo its changes, but we cannot really version it. What I mean by that, if we keep on changing file or we keep on committing, well, if we commit, we will apply the change in a file. But until we commit, we won't add a checkpoint for that file. And that's important. So let's make some changes. Added one line. Wait, sorry. Yes. Okay, you see it says this file has been modified. So I need to do git commit -m. I simply added one line. Done. I need to stage, sorry. So git add dot, and now git commit. Git status. Okay. So let me correct myself slightly. When you do a git add command, you not only add the file permanently as versioned, but you also add the whole change. You basically push the change forward to another location, the repository, and have more things that you can do with it, or rather say it's a checkpoint. That change is now accepted as a change, as a change that you made. And therefore, if I do git status, you know, let's do it one more time. So it says untracked, not staged. I added, stage the change, and if I do git status, it says modified. So if I want to accept that change, which is essentially what commit does, git commit, added one more line. And now if I do git status to see what's up, no changes. So I basically accepted the change. So one way to look about git stage, git add is like asking or pushing a meaningful change to be considered, and then git commit will accept whatever change you made and version it. So it's like a checkpoint, like you pass the checkpoint with git commit and it's versioned. And the cool thing is, if I look at the history of it, and I don't remember how you do history with Git, but let's do it slightly differently. With another tool that I have in mind, TortoiseGit, so it allows me to check history. Revision. No, this. Please log, I think. Yeah, it shows all the changes I did. So that's really cool. And it says the status of file as it went through these changes. Next. Git log. Okay, thank you. Git log. I'm not really a console person, as you can already see. Okay. It doesn't show everything though. But that doesn't matter. That's besides the point. The point is we now know how to version our files. Okay. Git log q. Okay, I will not attempt anymore. Doesn't matter. So now we know how to version files. We can version files, and this means that we have a lot of freedom. I can move back and forth in versions if I want to. And since I am not as savvy in console, from now on I will be using tools that help me to work without knowing the complex commands and without having me to memorize everything. So if we want to go to the last step, which is moving our files to GitHub itself, to the host, to a remote repository, we need to execute git push command. So this is the last command I'll be executing in the console. So if I do git push, it says that's the files that were moved to the repository, some repository. So lesson 6, test 3 is the repository that I should have just created. So if I click in my repositories, you can see I have this file with these 2 lines. I just moved the files, the changes, with the whole history of it as well. And that's pretty cool. what happens if the change happens from the other side? What happens if I added a change in here? In other words, what happens if your remote repository adds a change while your local repository doesn't have it? Or in other words, can you actually find out how to get those changes? Is there any way you could find out the changes that happened to a remote repository? And the answer is yes, you can, of course. And that is done with a fetch command. Fetch takes a peek at the changes, at the history of a remote repository and tries to compare it with your local repository. And it will say the differences of history that happened. And here you can see Git status, I guess. Right. It says your branch is behind one commit and can be fast forwarded. This means that there are changes that happened, and I still need to sync with those changes because I still have just those two lines, and I somehow need to sync with those two lines. And this can be done with git merge command. And you can see that 3 symbols were, well, I actually don't understand why 3, but that some code was added. And you can see that in the logs. Oh, it's line 3, I guess. Yeah. And that's it, basically. Alternatively, if I make changes once again, I can do a git fetch once again to peek if there are any changes. And it says again, yes, there are changes. And then I can do git pull, which actually does both things. It does a fetch and a merge. So at this point, running git pull is the same as running git merge because I already ran git fetch. So let me prove you that it works. As you can see, that extra line is added. And if I do this once again, this time I will say, well, I don't care what changes happened. I just want to be up to date. Maybe I didn't make any changes myself, so I can rest assured that there won't be any conflicting changes. So I can simply run git pull, which fetches and merges. And look at this interesting thing. It ran this bit and this bit. Look closely. Isn't this and this the same as this and this? That's pretty cool, you must admit. You can literally see the two commands output done with a single command. Question. Why stage and then commit? Why not commit immediately? When do you only stage and not commit? Um, it's a good question. But yeah, basically commit means you pass the checkpoint, so you're happy with those changes. But stage means simply I'm not sure about these changes. But I cannot answer this question properly, I think. You see, if we add a file, let's say it doesn't matter the format, and I do git status, it says the file is not tracked. So the question comes down to, so if I stage a file, effectively that means that I'm tracking that file's changes. And the question comes down to, are there use cases where you wouldn't want to track file changes? And I guess, yes, there are. Maybe it doesn't work well with ignored files, auto-generated files. Would you like to track all the garbage that's generated from tooling, like Visual Studio? Maybe that's why. So it's useful to have a distinction from what's tracked, untracked, and committed. So I would assume that's why, but that's purely logic speaking and not actual reason. So I hope I make a reasonable guess. But I assume gitignore a file which ignores other files, which I will add right now, will not work. So if we move forward, there is a file in Git called gitignore, which can be used to ignore files. Note how this suddenly changed. I removed this, and if I do git status, you see nothing happened. If I add a file called this, it will not be tracked. I have one file, gitignore, and let's say I have another file called j. Two files tracked. Why is this file not tracked? And the answer is because it's in gitignore. Whatever I put in gitignore, it will not be tracked. A simple way of excluding what you don't even want to consider tracking. It puts in a blacklist that says, we don't track you. It's great to put auto-generated files there, files which you can get locally anyways, heavy files like NuGet packages, like images. Maybe you can download images and you don't need them locally, and having a link is enough. But yeah, essentially, if you have auto-generated files, don't version them. No need. All right, let's move on. So fetch takes a peek at repository to see, takes a peek at remote repository to see how that differs from our local repository. And when you do a merge, we sync remote and local repositories. Or specifically, when we do a merge, after we did a fetch, we sync remote and local repository. We can sync in one step, doing a git pull command as well. When we work together, it's important to understand the purpose of code versioning systems. It's not that we can share code only, but it's also that we don't step on each other's toes. It means that code versioning systems allows us to separate changes. Separate changes, let's say we have a feature A and feature B, and something that happens in between, you know? So having a version control allows us to isolate these two things from whatever we are working on at the moment. And if feature A comes, feature B comes, they will be handled separately in isolation and may cause conflicts or not. It depends, but as long as we segregate things into branches, we can isolate different unrelated work. So what is a branch? If you take close attention, here and here we have, and here we have branches. So this is one branch, this is another branch, and this is a third branch. Different colors indicate different branches and their names. So this is a little feature branch, this is a big feature branch, and this is a master. Why is a little feature called little feature? Because it has just one commit. So these circles are commits. Our master has 4 commits. Our little feature has 1. Our big feature has 3. The key point here is that it is visualized really well. It's in parallel. We can work on both the mainstream branch and the 2 unrelated feature branches simultaneously without affecting the one that's working and that's published. So master branch should be strictly for code which works, for code which is tested, and for code which we are happy with. And these branches, they're wild. They can have experimentation and stuff like that, and eventually someone will need to take this branch and merge it into this one. But it will take time. When that happens, there needs to be a code review, and there needs to be a change request raised, and conflicts, if any, solved. A question. Do we all have to start from the same branch or project file? Will we not be able to do change requests otherwise? That is true. If, imagine if you have 2 unrelated projects, completely unrelated projects. One is Java, the other one is C#. What happens when you try to merge the 2? This would effectively mean that, let me show you what would that mean. It would mean that you would have another start. Sorry. Oof. So this is your start. Wow, so bad. Basically, you would have 2 starts in here and also in here. How do you sync those starts? Based on dates? Or based on what? It's too difficult. So it will say that you don't have a common base and it will not allow you to merge. Yeah, it simply doesn't know where the common point, where the start is, and therefore it doesn't work. So merging is literally taking two different things and putting them into one. Like in the famous anime Dragon Ball, it's like the fusion dance where two boys or guys or girls become one. But sometimes, you can merge stuff quite easily. Uh, let's say we go to our test file and add one more line, or no, let's remove this test2 and change this to test3. And at the same time, in line 4 on remote repository, let's also make a change. Refresh just in case. And let's add test4 here and save. So my changes are here. Sorry, I need Git Bash. And then I try to do git pull. It says merge failed, fix conflicts. So it will mess my file quite significantly. It basically says, this is what you change, and this is what you changed. This is what the other thing changed. The other place changed. Master changed. So you need to make a choice. Which of these changes do you actually pick? So I can say, look, I'll pick this. And then this. And then save. And then I do git add all git commit solve merge conflicts, and then I do git push, for example, to push my changes. So you can solve merge conflicts in this way. I actually didn't expect that that would be a conflict. I thought that it would just work, but didn't, so be it. Let me add one more example. Once again, a change in both places. So this place removes this file. And this place adds another file, test1. And if I do git add now, sorry, if I do git add, git commit -m, I say edit a new file, git pull, I guess. That's interesting. Please send her a commit message to explain why this merge is necessary. Okay. Close. Interesting. So git status, we're done. So I just proved that if the files aren't related, you can actually make changes in them because they're not breaking. Adding one file in one place and removing another file in another place is not a breaking change. So if I refresh, you can I didn't push yet, sorry. Git push. If I refresh, you can see one file there and the other one not there. Okay. It's time to work with our repository, with the one we had in a lesson. So I will delete mine, the ones that we don't care about, and I'll create a new branch. So this, how do I access this? If I click, so open Visual Studio, I highly recommend Visual Studio now. Click on View and select Team Explorer. And it should put you in a window like this. Click on Branches and navigate to Lesson 5. Click New Local Branch From and enter the branch name. What I'm doing here is a typical flow of what you will be doing when making a new feature, a new lesson, new set of changes that are unrelated to the previous set of changes. So let's continue. Let's say we clean up, let's say we remove unnecessary using statements. In Visual Studio, you can commit by going home, Team Explorer home, and then in this window, just type removed unnecessary using statements from startup.cs. I can commit or commit and push immediately. And this is pretty cool because it hid the staging step from us, which is reasonable because, as somebody asked, why should we care about staging when we know for sure that something will be staged? Tools allows us to work around that and, gives us a little shortcut. Shortcuts are great, but at the same time, they come at a risk that we will miss something essential when the shortcut doesn't do exactly what we need. In this case, it did. So I just created a new branch and pushed its content, and now it should be accessible in Git, GitHub, I mean. So if I go to our repository, you can see we have lesson 6, Git, pushed 1 minute ago. Great. What now? It's important to understand how to work with Git in an open source setting. From today, I will require you to submit your homework through GitHub by creating a change request. How do we create those change requests? The problem at hand is, how do you ask to integrate changes that you made if you are not the owner of a code base? What do you do? How do you ask those changes to be integrated? And this step now is not specific to Git itself, it's specific to GitHub. Every Git host will have its own way of asking for changes to be integrated. This is usually done through GUI, through graphical interface, in one way or another. If you want to work in an open source setting, you will need to copy someone else's repository in your own repository. So please note, this is CSN repository. It's an organizational repository. If I want to start working on it, and if I'm not already a member of this organization, I need to fork this repository first. So I click fork. And I already have it forked, but I will choose a different organization for now. So it's being forked. And note that this has a different start compared to this. And below it says this repository came from this place. This means that I'm not the owner. This means that I'm someone who wants to make changes. So let's add some changes. Let's create a new file. And let's say hello. Let's say this is my homework. And I would say edit example file. Name your file, right? Homework. Let's say added homework, implemented homework. Cool, I have my homework implemented. Now let's say I'm happy with this homework file done, and I would like it to be submitted for a review. I can do new pull request. So you see, I have this new file, which I just added seconds ago. If I want to ask for changes, I need to go to pull requests or requests for changes. And then I do new pull request. And then there is like an ask. It asks me, where would you like to get these changes from? I would like to get them from, where would you like to request those changes to be added? I would like those changes to be added to the owner CSN from hero to hero repository. So that's my target, and my location. Where is the change originating? It's originating from Realm of Everlasting Code, this repository. And make sure that you are targeting the same branches. Usually it's the same branch when you work on a fork. It could be a different branch as well. It doesn't matter as much. Just make sure that you select the right branch. So, and you can see, this is the file. These are the changes in that file. And if you click create pull request, you will need to name it somehow. And ideally leave a comment. It's just a test. And create a pull request. Now, as the owner, I will be able to check the files changed and review it. And I'll say, this is not compliant, missing XYZ. And I cannot really approve or disprove my own changes, so I cannot do much. When I'm happy with your homework, I will approve it right here. If I'm unhappy with it, I'll require changes. In any case, sorry, not in any case, but if your homework is closed, or if your homework hasn't been changed in a while, I will close the homework submission, the pull request. So I'll close this one for now. And that's it. That's how you work with open source. Through pull requests, through forks and pull requests. The rest is the same. Does it update forked repository immediately when the original is changed? Unfortunately, it does not. I think, yeah, I have a guide put what you need to do to go through in order to work with a repository for Visual Studio. This time, Wiki is very thorough, and you should manage just by going through it. So there is a guide for Visual Studio, how to work with Git in Visual Studio, and it's a very for dummies kind of guide. So it shows where you go, what you do, with screenshots and every step and explanations why and what you need to do. So the part that we want to care about is how do you sync with the original fork. So you will need to go to settings. It doesn't happen often, so I also forget things like that. You will need to go to settings and add a new origin or remote. So I will, let's call it remote. So remote homework, let's say. My homework. So I will need to add a link. I'll just follow what I wrote actually. Just call it, you can see what I did. Add a remote, name it whatever you want, for example, upstream. And when you want to sync with the repository, another repository, you can then select it that I want code from this one, or I want code from that one. So you can click fetch and pull and it'll work. So let's do that. Right, let me go to my organization. This one. This one. And give GitHub Git a link to the setup. So link, save, done, and you can see my remote homework. So now if I go to a home button and click branches, sorry, not branches, but sync. Maybe not that. Sorry for confusion. changes. No, not changes. Not committing. There should be one more thing appearing here. Maybe it didn't synchronize itself yet. I should be in synchronization screen. Yeah. And it's not appearing yet. So I think I need to reopen Visual Studio for it to appear. How can we add the changes you request? I will show soon. Sync. Oh, right. So if I click fetch, I can now select from where do I want to fetch. So this means basically, do I synchronize with a remote repository? Sorry, a repository of the owner, or do I synchronize with a repository of myself, of my own? So from time to time, you will need to select origin and click fetch, just in case to be sure that you are still in sync with my changes. And you will probably need to do that weekly, so don't forget that. Cool. So let's say I want to make changes. And I want to get my own changes from remote homework place. And I pull, it's up to date, great. Let's make further changes somewhere. Okay, these aren't not needed. And let's say I commit. Sorry. No, 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 no. No, 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 no. Clean up. I commit. I push to remote. Push. And then from my remote, I will create a pull request. This one, I can now create a pull request, which was closed recently, doesn't matter. But now I will change, I'll select a different branch. I'll select this branch and I will select a matching branch as well. And you can see only these namespace removals were the things that changed. So using statement removals. Okay, I'll create a pull request. And let's say I comment on something. Why was this removed? Please undo. Or clean up in all places. My comment is I want consistency. I want you to clean up in all places, for example. What you can do then is, okay, you saw my comment and you go through files and look for unnecessary using statements and you remove them all. So you remove this and that, and we're good. So I removed everything and I say removed last missing last unnecessary using statements. And I commit, and I go to sync screen. I then choose push, and I push to my remote homework. This is my remote homework, lesson 6, Git branch. Question: where is my pull request coming from? It's coming from also lesson 6, Git. So if I make the requested changes and push them to the same branch, they will appear in my pull request. So please have a look at the summary. There was one file changed. There was, come on, comment, sure. There was only one file changed, as you can see here, but now I changed a few files more. What will happen when I push to the same branch? To my homework branch, I push once again. Let's refresh. You can see now 3 files are changed. So I just basically updated my homework changes. So if someone requests you to change homework, to make changes, you can simply do the same flow as before and just push. Make changes, commit in your branch, and just push, and it will be updated. You don't need to make a new pull request. However, a beginner mistake is often when they make changes, they forget to reply to remarks. Remove changes in all places consistently. Not changes, but using statements. So if someone asks you to do something, do not just resolve remarks like this. Add a comment explaining what you did, and only then resolve the conversation. Or worse, don't resolve it at all. That's the worst thing. So if you do make changes, or if you are, disagreeing with a remark, please reply to it. Otherwise, the reviewer will not know if you didn't agree, if you didn't know, if you were confused, afraid, tired, didn't have time. We will not know what went wrong. Why didn't you make those changes? Maybe you didn't see them. So please reply to remarks. Documentation. So another thing about commits, sometimes we have unrelated things. Like sometimes we change comments, add comments. Other times we remove one using the namespaces, and other times we also clean up code or add new features, and all those things are distinct. So try to separate things that matter from things that don't in commit messages, different commit messages. And don't just make one massive commit for everything. Commit small things and frequently. A rule of thumb should be, as long as you have something working, make a commit. And that is your checkpoint. Let's continue. Let's say we have a breaking change, and how do we resolve those in Visual Studio? So in here, I will change the license a bit. And I'll say, oops. And in here, I'll say the license. There is no license file here. Okay, doesn't matter. Let's change startup. Test. I'll commit. And let's do the same change in here. But slightly different. Starts application. Doesn't matter much. Okay. So, if I try to get my changes from my remote homework, I know that it will not work. Like, I committed. Let's restart. Okay, it's there. It's in here. I am fetching from my homework. Okay. Let me pull. 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 Okay, why aren't you working? Let's push them. Okay, it pushed. That's weird. Maybe I didn't commit it. I did commit it. Why is it not... why is this guy not being committed properly? Let's say push to this place. Ah, pull and push, finally. It should say breaking change. Push cancelled. Okay, something is wrong and I don't know what. And in cases like this, sometimes tooling like this fails. I don't know what's wrong. Let's see what we have here. Still the same thing. Okay. So when only, like my rule of thumb, when tooling fails, only then I go with console. And I will Google up git pull doc. Okay. Upstream. This is overwhelming. Repository. Git pull and then repository. And my repository is this one. So let's try. Unrelated histories. Why is it unrelated histories, you may ask? And the answer is, I don't know. I don't know. Anyways, when in doubt, there's always a point in time in a branch that, you know, you're confident that it should be working, or not confident that it should be working, but you have a working code. So this is a fail code. This is what you want to go back to. So if you want to go back in history, you can go and do a reset. Let's do a reset. And it basically eliminates those two last commits. So if I refresh, boom, they're gone. So if I do a push, I'm not sure what will happen. I'll try to pull now. Yeah, repository updated. And if I push, oh no, I pushed the wrong place. Oops. To here. Pull and push. Ah, still the same problem. Right. Let's refresh. Yeah, those are bad. I want to remove those completely. And I want to, not here, bust out console and do a forced push, which deletes those two incoming thingies. It's in the wrong place. Let me open this in here. So bash git push -f, and I need to specify a place where I push, and I push to this place. So it erased the history altogether of those two failed commits. And if I refresh, they should have been gone. Let's try slightly different thing. It might be because they're from a different place, from origin, and I'm talking about this one. I guess the command is failing because it fucked up in history. Let's try this as well. -f. Basically erasing those two last commits. They should be gone. Okay, if I refresh, you can see they are gone. We're back in action. Okay. Yeah, so now I should be able to go back to my branches. Sorry, to my sync. Select this and fetch. Okay. Pull. Fetch. Pull. Push to this. Push. Okay. Okay. Maybe I'm fine now. So let's make a change somewhere. Oh, I'm in main. Sorry, I'm in main. I want to be here. Let's make a change in here. 111. Commit. Let's go here. Let's go here. Let's go here. Sorry, let's go sync. Let's go fetch from that repository. And it doesn't show anything. Huh. What happened? What happened? Let's go to the settings once again. Maybe I messed up something in here. My remote homework. No, I didn't mess up anything there. Huh. Fetch. Let's try in here. Git fetch. So git status with origin. Okay. Git fetch. And then paste that thing. Git pull that thing. Please commit. Okay. Close. Okay. Something happened. So I do a pull. Sorry, I do a push. A push to this place. Sorry, a push to this place. Pull and push. Ugh, push cancelled once again. What bothers me that, right? So what do I have in my history now? I have those guys. So if I push, this is weird. Let's do a push. Git pull from this place. Already up to date. Git push -f. Fuck. Git push in there. Okay. Git status is fine. So, okay, that's fine. So if I do a fetch now, Nothing happens if I do a pull now. Nothing happens if I do a push now. Nothing happens. Or rather, it said succeeded. Okay, let's make a change. Test. And let's make another change in this same place in a remote repository. Sorry for this confusion. This is unnecessary tedious. But it's good experience because it shows the bullshittery you might be dealing with yourself. So I committed on my remote repository a file change in one place, and I'm committing another file change in another place. And now I'm syncing, I'm fetching from this remote homework. And I'm pulling from it. Okay, push. It will be cancelled. I don't understand. Why is this happening? Just rename it to upstream. Push to upstream. Yeah, call IT. Push cancelled, and to say histories are not matching. Git pull. Git push force. Yes. Let's refresh. Test one. Test one. I am not sure what's going on right now. Because we did an analogical example already, didn't we? I'm just trying stuff right now. Sorry. So I'm getting changes. Yeah, I think it's bugged somehow. I think it's super bugged. So what you should be doing, I guess, when stuff like this is happening, remove this altogether. I think the problem is because my local and remote are like maybe the same and it's confused. The upstream and origin are set up correctly, yes. Okay, cancel, cancel, cancel. Let's do this, because that's not, the normal flow that you'll be following. What you will be following, you will take this and clone it. Yeah. I'll use a third tool now, which is Tortoise Git. So it integrates with Windows nicely. And I'll call this lesson. BC lesson 1. BC lesson homework. Okay. Ok. Yeah, and it's taking from that one. Close. Okay, let's open it. Let's go to branches. Let's go to the lesson branch, the lesson 6 branch. Come on, check out. It's checked out, you can see here. Okay. Let's go to settings. Oh, okay. I have an assumption, a hypothesis, which will be proven by facts and not really logic. So my upstream, the other one will be, so this is actually what you will be doing. You first check out your own homework, because that's your main. And then you go to my branch, sorry, my repository, and add that to yours. So origin and upstream. And let's mess with it a bit. Why is it empty? Shopping API, that's why. Let's open this. Let's go here and let's mess something up. Let's delete this. And let's commit it, but not push it. And in here, let's go here. And let's add 3 here. Cool. So we have this commit. Let's do a fetch from origin this time, because we want, that's our code. We own that code. Origin comes from us. Good. So what hypothesis can we make from this? Or not hypothesis. The hypothesis was, what if we change origin with upstream, the places? So my first repository was the one that was original, but I treated that first one like a homework and it didn't work. But my second one has been cloned from the homework, and I treated that as origin. And there were different results. I actually did not know that, and I learned something myself. So, given you are the owner, you own the origin, and my repository, the one you will be making homework to, like you will be submitting to me the homework changes, that will be your upstream. And now I have conflicts, and I can solve those conflicts. So if I do a pull, it will say, hey, solve merge conflicts. And this is already familiar. This is my change. Sorry, this is my change, which is I removed that line, and this is the commits, the branches changes, the remote changes. They changed this by adding a free. So I need to resolve these, conflicts. So how do we resolve conflicts? Click on conflicts, click on the actual conflict and select merge. And then select, do you want this or do you want that? And I say, I want that. And at the bottom, you can see the result. The result is one line will be removed, and that's all. When you're happy, click accept merge. And it cleans the file properly. And then just click commit merge. Merge from master. Or rather, accepted line removal. Commit, sync, push. When you think about it, you should never be pushing to upstream, and that probably makes sense because you did not initially want that to happen. So I guess it makes sense, but it's confusing. It's still confusing. I did not know that. Anyways, it's great because problems like that you will face yourself as well, and we resolved those problems. We just had a merge conflict and we resolved it. So let's say I made changes and I'm unhappy with them. Let's say I want to go back all the way at start, basically to this place. So I can do a reset. And there are two kinds of resets, three kinds actually. There is mixed, hard, and soft. And I don't even remember what soft reset does, but mixed reset goes back and past, but keeps your changes. It just goes back and past in history and allows you to change the stuff before it was committed. And hard goes one step further and deletes everything. So let's do that. If I click mixed, and if I click changes, you can see the changes that this file was added. But if I go here and do reset hard, it removes the changes. And if I refresh, the history is dead. It's not dead yet, but if you do push, it will be dead. But you cannot just push. And I'll show you why. If I do a push, it will not work. It says there is history. And indeed, there is still history. You need to resolve this somehow. So what I can do is git push -f, which is forcefully pushing these files through. Forcefully means I drop this history. So if I refresh, it's gone. It's not gone yet. Why is it not gone yet? It should have been gone. Because I am in the wrong place. That's why it's not pushing it properly. Okay, I need to open it here, not GUI but bash, and do git push -f. And now it should be fine. So if we go here and refresh, the commits are gone. Cool. We know how to undo stuff, how to fork, how to version code, how to read history. Is there anything else that we should know? Let's see what I wrote in here. Here. So we managed to solve those conflicts. We know some tooling, branching, right. So everything is in the wiki. All you need to know is in the wiki. But the key point is to understand the meaning of Git. Git, again, is just 3 areas between files travel. It's working directory, staging area, and your repository, local and remote. I would recommend as a beginner to use Visual Studio as your version control tool, because it might be intimidating with all those commands, and Visual Studio is okayish. And another tool I would also recommend is TortoiseGit. Like if you right click and after you install TortoiseGit, you should see a context menu with 3 items, which nicely integrate and has all you need really. Like you can see show log and it just says what happened, what you did. I recommend playing around with Git branching and Git flow guide. And these guys are inside at the very end of the wiki. Anyways, there is a guide for everything. There is a guide for Visual Studio GitFlow. There is a guide for TortoiseGit GitFlow. There is a guide for even Git Kraken if you so wish, which I didn't add a link to yet. So tomorrow I'll update this a bit to include a few missing bits, but essentially this is a good learning source that I recommend you going through. And if you have any questions, please do ask. So before I go, do you have any questions? For those of you who are new to this lesson, also please let me know. Who are new to Git, please let me know. What did you learn today? And yeah, what did you learn today? It's a lot to grasp, but it was very hands-on and it literally touches everything you need for 99% of scenarios when working professionally with Git. Cool. Cool. I'm happy, guys, that you learned about Git in a broader sense and about pull request process and practicality. So thank you for watching and see you next week where we delve deeper into object-oriented programming. This time for reals. We're gonna take the 4 pillars and learn them heads on. See you in the next lesson on Sunday.